Yes, hi guys. Today I'm talking about the solution of simultaneous linear equations. Here are linear equations and with the help of matrices are solved them, that how to solve them. Okay, and the solution method is simply one has to understand that what is inverse of a matrix. With the help of inverse of a matrix, these equations are solved. These equations are solved. Okay, the process let me talk about. The process, first of all, whatever the equations are given, let me take a simple uh, okay definition of this. How to solve simultaneous equations, simultaneous linear equations with the help of matrix. That is the topic of today. The process is, suppose let me take x plus y plus z equal to 3, 2x plus y plus 3z equal to 4. Let me take, this is 3 by 3 order of order 3 by 3. Okay, this is 3x plus y plus z equal to, let me take 5. This is the equation. Now these three equations we have to solve them with the help of matrices. What we do, suppose the coefficients of x, y, z, we write them as matrix A. Okay, so let me write it as 1, 1, 1, 1. Here the coefficient of x, y, z of first equation. This is equation number 1, second, and equation number 3. These are three simultaneous linear equations. We have to solve these three equations. What we do, the process here, we write it as the coefficient of x, y, z in the left hand side, we write them in the matrix form. This is 2, this is 1, 3, this is 3, 1, 1. Okay, and into x by z, these are the coefficient. We write them as column matrix, as x, y, and z. Because if I multiply first row with first column, I'll take x, y, x plus y plus z equal to, and the right hand side, these values 3, 4, and 5, they are also written in column form. This is column matrix. In this way we write them, because if I multiply this matrix to column matrix, this one column here, then we will get these equations. So equal to them, we can equal them, this first value is equal to 3, is equal to this. So then equations will be obtained in one you may say column matrix type. Okay, then x equal to this, this equation equal to 3, this equation equal to 4, this equation equal to, so this whole equation we have written in this form. Now if I write this matrix, matrix of this elements as A, let me take this A matrix, and this is capital X, and this is equal to, let me take B. This column matrix is B. In short form we write them like this. Now if I find out what is x, values of x, y, z with the process, so where, let me write here, where A is the this square matrix, this is 1, 1. It must be always a square matrix, because inverse of a square matrix only can be calculated. This is 1, 1. And x, capital X is x, y, z. This is the column matrix E. And the B is the column matrix 3, 4, and 5 in this case. Okay, these matrices. So these matrices we have written down here. A(x) equal to B. If I further solve it, let me multiply this by A inverse, or A inverse into A(x), let me multiply equal to A inverse into B. If I multiply to both sides, left hand side and right hand side of this equation, by A inverse. So this is A inverse into A, or we can write it as A inverse into A into X equal to A inverse into B. It means A inverse into A is I, identity matrix, we know. This is equal to A inverse into B. But I into identity matrix into any matrix is equal to the matrix itself. This is X equal to A inverse into B. So this is the solution we will find out. Solution of the, this is the equation. We will write all these kind of equations in this form. X equal to A inverse B. We will multiply this A inverse B. We have to find out now A inverse. Then this column matrix is to multiply to A inverse value. And whatever solution comes out, that will be equal to this column matrix X by Z. And then we will equate them simultaneously or separately. This is solution equation, solution of the solution matrix form of the given equation, solution of the given equations. This is of the given equations. Okay, so this X equal to A inverse into B. How we have done this in I is identity matrix into X equal to A inverse into B. In this way, we will calculate all these questions. Now let me take questions one by one. We solve them with the help of inverse of the matrix or with the help of matrices. So this is the process here. Okay. We will write the X by Z, the variables. We have to find out the value of variables. That is known as solution of the given equation, given simultaneous equation. Find the values of variables X by Z. We have to solve them with the help of matrices. This is a simple question. We have not to solve the linear equation with the help of those three methods. Okay, those three methods are the elimination of the any variables, that is known as elimination method. Okay, or simultaneously substitution method, that was known as sum to substitute method. All those methods which we have discussed in algebra, those methods are there, but with the help of matrices, how we have to solve them. This is the process here. So let's take question number 1 and solve it. That is done, it is verified. And these questions are taken from student queries, mostly from engineering, AMIE students, engineering students, BTech students. All these questions are from there. Okay, so simultaneous solution of simultaneous linear equations, the help of matrices, is being demonstrated here. So please just have the patience, and the process is very systematic. If one has to understand what is the inverse of a function, then one can solve these questions. Now let me take question number 1. It says the simultaneous equations are here X plus Y plus Z equal to 3. This is first equation. Then is X plus 2Y plus 3Z equal to 4. This second equation. Third is X plus Y plus 9Z equal to 6. This is the third equation. Okay. Question number 1. Question number 1. X plus Y plus Z equal to 3. X plus 2Y plus 3Z equal to 4. X plus 4Y plus 9Z equal to 6. These are three equations. We have to solve them. So, as I tell you that X equal to A inverse into B, where or AX equal to B, or AX equal to B, we just write what, where A is this matrix 1, 1, 1. This is 1, 2, 3. This is 1, 1 and 9. Okay, and X is nothing but column matrix X by Z, and B is the column matrix 4, 3. First element is 3 and 4 and 6. Okay, so in the right hand side, these values are values of these equations. So that are written in matrix in the column matrix form. This column matrix is also column matrix. And if I make X equal to B, and we will say that X equal to 3, Y equal to 4, Z equal to 6, solution is there. Then similar kind of situation will arise after solving this A inverse, finding the A inverse of A. So let me find what is determinant for A inverse. We have to know that what is A inverse. Since A inverse is equal to adjoint of A divided by determinant of A. that for that determinant is required. Determinant A is equal to, therefore determinant A first we have to find out from here. This is 1 into 9 to the 18. This is 18 minus 3 1 is 3 minus sign 1 into this minus 1 and this, so this is 1 9 1 is 9 minus 3 1 is 3 and plus 1 into this plus 1 into this is 1 1 is 1 minus 2 1 is 2. Solution finally 18 minus 3 is 15. 15 into 1 is 15 and this is 9 minus 6, 3 is 6, 6 into 1 is minus 6. Here it is minus 1 because 1 minus 2 is minus 1, minus 1 into plus 1 is 1, minus 1. It is minus 7, it is 8. Okay, so determinant value of A is 8 only. So let me write here, determinant value of A is 8. That will be required. Now let me find what is the adjoint of A. So now for adjoint of A, now let me rub this. Only A we have to keep here. Now for adjoint of A, for adjoint of A, the matrix of cofactors, the matrix of cofactors of A, let me denote that as A11, A12, A13. This is A21, A22, A23, A31, A32, and A33. Okay, this is there. Now let me find out what is A11, A12, etc. Cofactors. After that, I'll transpose this and adjoint is obtained. That adjoint into this 3, 4, 6 solution of that will and divided by 8. That will give us the right hand side. Okay, that kind of situation. Then X, Y, and Z, the column matrix equal to that value. We will then equate them X, Y, and Z. Value of X, Y, Z we calculate. So let me solve them. Here A11 equal to cofactor of 1. It is 9 to the 18, 18 minus 3 is 15, positive 15. A1 we just calculated there. Then A12 of 1 is 9 1 is 9. There is negative sign with minus sign because it's negative. 1 plus 2 is 3. 3 minus 1 is 4, 3 is minus 1 with minus sign. 9 goes up to 9 minus 3. It is minus 6 here because difference in the bracket is 6, but minus sign is minus 6. And A13 of this one is equal to is positive, but 1 minus 2 is minus 1. It is minus 1 here. Then A21. A21 is also negative because this is 2 plus 1. Minus 1 is or 2 plus 1 is negative value of this one. It will be this cancelled out, this column cancelled out. 9 1 is 9 minus 1. This is 1. So 9 minus 1 is minus 8. Sorry. And then A22. A22 means for 2. Cofactor of 2 is 2. This is 9 minus 1. 9 minus 1. Okay. 9 1 is 9. And this 1 into 1. This is equal to 8 positive. Then A23 for 3. This 3, this is a 1 minus 1 0. There is nothing, minus 1, 1 minus 1 is 0. Then A23, sorry, A23 we have taken, now A31. A31. A31 means for 1. This is 3 1 is 3, this is positive, but 3 minus 2. 3 1 is 3, minus 2 1 is equal to 1 positive. Then A32. A32. A32 means for 1. This. For this 1, this column, leaving column, and this leaving row, we will get 3 1 the 3 minus 1, it is negative, but 3 minus 1, 3 1 the 3, 1 into 1, 1, 3 minus 1 is minus 2, it is minus 2, then A33, for last element 9, the cofactor of 9, this cancel out, this is 2 minus 1, it is equal to positive, but 2 minus 1 equal to 1. So, matrix of cofactors that we write here, this A11 is 15, A12 is minus 6, then A13 is minus 1, A21 is minus 8, A22 is 8, A23 is 0, A31 is 1, A32 is minus 2, and then A33 is 1. Okay, this is the matrix of cofactors, but we will transpose it. Therefore, adjoint of A is equal to, therefore adjoint A is equal to, let me transpose this, I will transpose this. Transpose this will be 15 minus 6 minus 1 is minus 8 and 0. Writing rows and columns as columns, rows as columns. First row, first column, second column, third row, third column is 1, minus 2 and 1. So this is your adjoint. Adjoint of A is this. Therefore, now what we have to find out, therefore solution. Let me find out the solution here. Adjoint is this, therefore x equal to x means x, y, z. This is equal to A inverse. A inverse is adjoint of A upon determinant of A. That means 1 upon 8. In bracket this value, this is adjoint of A. This is 15 minus 8, 1, minus 6, 8, minus 2, minus 1, 0, and 1. Okay, into B. This B, now B is here 3, 4, 3, 4, 6. Now multiplying these two, the divided by 8, this element, it will give us x by z equal to. Therefore, finally solution, this will be 1 upon 8. Let me now find out. This is first row, first column multiplied, first element is obtained. Then second row into first column, first element of second row will be obtained. Okay, and then third row into first column, we will get the third element of the, first element of the third row. This equation. So let me add them. 15. We have to multiply them correspondingly and add them. 15 into 3 is 45. Minus 8 into 4 is minus 32. 1 into 6 is plus 6. Okay, we will add them. One element will be obtained. Now let us take second row. Second row corresponding multiplication. Minus 6 into 3 is minus 18. 8 into 4 is 32. Minus 2 into 6 is minus 12. And minus 1, this third row now. Minus 1 into 3 is minus 3. Plus 0 into 4 is 0. Plus 1 into 6 is 6. It will give us 1.8 into 45 minus 45 plus 6. Yeah, 45 plus 6, 51. Alright, is it answer to the 32? Okay, let me first find this value. 5 minus 2 is 3 and 30. 30 plus 6, 90. It is coming a different value. No problem. 5, 3, 15 is 45. A minus 8 for 32. Alright. Plus 1, 6. Okay, so this is coming 19 because this is 6 only, and this value 5 minus 2 is 3, 45 minus 30, and this is 1, 13. 13 plus 6 is 19, this is 19 value. No, okay, multiple of 8 is coming, but it must be there. It must be okay, let me check answer is right or wrong. That we will decide later. 15 minus 8. Okay, let us take next question. This one, this is minus 12, 32. This is only 2. Minus 18, minus 30, minus 12 is 30, negative 30. 32 minus 30 is 2 only. Minus 3 plus 6 is only 3. Also, it's coming a different one. Sorry, different value is coming. The inverse is not coming properly. Maybe this is wrong. What can we do? Therefore, 19 upon 8. First value is 19 upon 8. This is 2 upon 8 is 1.4, and this is 3 upon 8. These values are of x, y, z. This implies that x equal to 19 upon 8, y is equal to, because if I equate x by z equal to this column matrix, so each value will be equal to x equal to 19 upon 8, y is equal to 1.4, and z equal to 3 by 8. Good. Okay, so A inverse we have just obtained value of x, y, and z, but they are coming in coefficient form. Okay, ratio form is not digestible, but maybe let me take the second question that will clarify that whether values are coming in the same way or if I have committed some error. Okay, no error because we have taken the coefficient here 1, 1, 1, 1, 2, 3, 1, 1, 1, 9. 1, 1, 9. That is there. What can we do? Let us take these are on to the here. First question is solved. Let me take the second question. From there it will be clear that the answer is coming, because mostly answers come in real numbers form. Okay, or I mean integers form, but they are not coming in integers form. They are coming in ratio form, That is not acceptable, but maybe let me take second question. Again, solve with the help of matrices, the simultaneous equation. This we have 3 equations. Again, second question is twice x minus y plus 3z equal to 9. First equation. Then x plus y plus z equal to 6. Second equation. Y plus z, then x minus y plus z equal to 2. The third equation. Okay, third equation. This is 2x minus y plus 3z. 2x minus y plus 3z equal to 9. X plus y plus z equal to 6. Right? X minus y plus z equal to 2. Okay. Again, we have to write them in the equation form. What is that? X equal to? So let me write in matrix form. This is 2. Sorry. This is 2 minus 1, 3. This is 1, 1, 1. This is 1 minus 1, 1. Third equation is x minus y plus z. Okay. X minus y plus z. Okay, and this is into x, y, and z. These equations are written in this form, matrix form. This is x here is equal to these values 9, 6, 2, 9, 6, and 2 are coming here. Therefore, x equal to A inverse into B. Using this, we can get x, y, z, or x equal to A inverse is inverse of this equation. This is A here. A inverse is equal to, that means A inverse This is 2 minus 1 3 and 1 1 1 1 minus 1 inverse of this into b is this 9 6 and 2 9 6 and 2. Alright, this we have to calculate. It will be value of x then. Let me take inverse of this one. So first of all, let me solve. This is a is equal to, okay, now let me solve it. So solving this equation, finding the determinant value. So determinant of a is equal to 2 into 1 minus 1 is 1. This is plus 1. Minus 1 into 1 is minus 1, but minus sign in between we put this is plus, then minus plus 1 here. This minus sign already, but we keep here minus sign in between, so this is plus 1 into minus 1 and this is minus 1 and plus 3 into this 3 into minus 1 into minus 1, this is minus 1. Okay, I'm sorry. What I've done is in between value is 1 minus 1 is positive 1 and this is minus 1. So I'm sorry, this is 0. For minus 1, coefficient, sorry, cofactor or minor of minus 1 is this 1 1 and 1 1. So 1 minus 1 is 0. Maybe that in that way it may be a mistake there, but value was okay, was 8 only. This is 2 into 2 4, so 1 plus 1 2, 2 into 2 is 4. This is 0 here plus 0, and this is minus 1 into minus 1. It is minus 2 into 3 minus 6. Minus 1 is minus 2, but into 3 is minus 6. The value comes out to be minus 2. Minus 2 is the value of determinant. The determinant value of this is minus 2 here. Now let me take inverse. So for inverse of A, you have to find out adjoint of A. For adjoint of A, okay, matrix of cofactors, of A, that we write that again as A11, A12, A13. This is A21, A22, A23, A31, A32, and A33. Okay. Now let me find what is A11. For A11, this cofactor of 2 is 1 minus 1, and this is plus 1 because 1 into 1 is 1, and minus 1 and minus sign in between we keep this is 2. Then A12, for this minus 1 it is 0, 1 minus, this is 1 into 1, 1 minus 1 is 0, but it is minus sign we keep 1 minus 1, but it is 0. Then A13, for 3 of cofactor of 3 will minus 1, this positive value, cofactor of 3 is minus 1, it is minus 2 here. Then A2, which is again negative, okay, because it's odd number, 2 plus 1 3, so odd number. For this 1, it is minus 1 and plus 3. Why? Because 1 into minus 1 is minus 1, minus 1 into 3 is minus 3, but minus sign in between we keep. It is plus 2 difference, minus sign is minus 1. A22, it is positive. A22 for this 1. Coefficient of 1, it is 2 minus 3. It is minus 1. 2 minus 3. Okay, then A23 for this 1, it will be minus 2, minus sign is there, minus 2, minus 2, and this is minus 1, so it is plus 1. Then it is minus 1 into minus sign is plus 1. A31 for this 1, it is minus 1 minus 3. It is minus 1 minus 3 equal to minus 4. Okay, it is minus 4 here. Then sorry, it is A31 for this 1. Yeah, 1 we have done. Alright, this one. Now this minus 1 is okay. Minus 1 for this is A32. This and this cancel is 2 minus 3. It is A32. A32 is negative sign, minus sign here for the bracket, negative sign. Now for this 1, this cancel out, this cancel out, it is 2 minus 3. 2 minus 3, it is minus 1 in the bracket, it is plus 1. Now A33 for this 1 is 2 plus 1. With 2 plus 1, with minus 1 plus here is 3. While 3 plus 1 for this 1, cofactor of 1 is this 2 into 1 is 2, and this minus 1 minus 1 plus 2 plus 1 3. Okay, so therefore matrix of cofactors will be, this is 2 here, is 0, 1 3 is minus 2, A21 is minus 2, A22 is minus 1, A23 is 1, positive, A31 is minus 4, it is 1, then A33 is 3. Okay, 2 0 minus 2. This is your cofactors, matrix of cofactors. Now we have to transpose this. For transposing this, then adjoint of A is obtained. That means of these. So adjoint of A, therefore adjoint of A is equal to transposing this 2 0 minus 2 minus 2 minus 1, and this is 1. This is minus 4 1 and 3. Okay, this is adjoint, and divide by minus 2 to each term. But let me first find out. Therefore x equal to, this is minus 1.5